Now doing our question 5. Before we do our question 5, it is also necessary that we make a little revision. The revision we're going to make is that one of a nature of root. We know that nature of root describe the values of x. How are the values of x? And what kind of values does x have in our equation or of our graph? So to describe the nature of our roots, we use the quadratic formula. But only this part here of the quadratic formula, which is square root of b squared minus 4a, it is necessary to describe the nature of our root. So in describing our nature of root, first we'll find that our roots can be real or non-real. So our roots are real if b squared minus 4a is greater or equal to 0, and our roots are non-real if b squared minus 4ac is less than 0. Also, our root can be equal or non-equal roots. Equal roots is when b squared minus 4ac squared is equal to 0, and non-equal root is when b squared minus 4ac is greater than 0. And finally, our roots can be rational or non-rational or irrational. So roots that are rational is when b squared minus 4ac is greater than 0 and b squared minus 4ac is equal to a square. This can be a 4 can be 2 squared, or 9, which can be 3 squared. And our roots can be irrational if b squared minus 4a is greater than 0 and b squared minus 4ac is not a square. For example, if we have 11 or 10, our roots are irrational. Now doing question number 5, we are given that 2 is the root of 2x squared minus 3x minus p, and we are asked to determine the value of p and hence the other root. Therefore, since 2 is a root, that means if we substitute 2 here in our 2 here, that will give us 0. So therefore, we will have 2 multiplied by 2 square minus 2 minus p equals to 0. Therefore, we have 8 minus 6 equals to, taking our p to the right side, we have p. Therefore, our p is 2. And the other root, that will be 2x, the equation, 2x squared minus 3x. Therefore, the value of p, which is minus, this is 2, equal to 0. Therefore, factorizing this will give us 2x. X, this will give us 2, and then 1. Since our middle term here is negative, therefore we have minus 2 and plus 1. Therefore, x equals to minus 1 over 2, or x equals to 2. Our answer here is question C says determine for which values of k the roots of x squared plus 2x minus 15 equals to k multiplied by x plus minus 4 are real. So to do that, we are going to use the discriminant, of course, minus 4ac, but we are told that the discriminant must be equal, greater or equal to 0, since we are looking for real root. Therefore, we are going to work out our equation here. That will be x squared plus 2x minus 15 equals to kx minus 4k. So therefore, we have x squared plus 2x. Our k to this side, we have minus kx. Here we have 15 15, say 15, therefore minus 15 plus this one 4k equals to 0. Therefore we have x squared. Here we have 2, we have x, 2 minus k minus 15 plus 4k. We have our a here, our b, and our c. Therefore, using the discriminant, so you say b squared minus 4ac greater or equal to 0, with our b being 2 minus k squared minus 4a is 1, c is minus 15 plus 4k. This one giving us 4 minus 4k plus k squared minus and minus giving us positive 60, minus and the positive giving us minus 16. All this greater or equal to 0. Now putting this in a correct form, we have k squared, this one k here, so 4 minus 4k and minus 16 giving us minus 20k, 4 and 60 giving us plus 64, greater or equal to 0. Now factorizing this, we have k squared, we have k multiplied by k. The factors of 64 in this case we'll have 16 and 4. All is greater or equal to 0. Our number here, our middle term here is negative, therefore we have minus 16 plus 4. Therefore, using our graph, we're gonna say write it like this. For all this value of k, we'll have this, where we have what? Okay, here is a minus and a minus giving us a positive 64. Therefore, here we have 4. No, here we have 16, and here we have 4. So we know that for this graph to be greater, this side here, to have these values greater or equal to 0, our k, first our k will be for k, our k will be less than or equals to 4, or our k will be greater or equals to 16. Yeah, that's our answer.